So now let's see how our weather station application works on our Raspberry Pi. So here we have the device, and here we have the 0.96-inch OLED display and a push button. And we have our program that is being opened right in front of us uh, for making it work. So now I need to click the run command. So here we have the global weather station.py. So when I click run command, so we can see the status of our program at the bottom, right, in the shell part. Now coming back to our device, so here, so now we will be able to access the weather data. So now when I press the button, it gives us the detail of weather of the city Chennai. So Chennai is in India, so it displays like Chennai with a country code -IN. Again, when I press, it shows for Delhi. So DESC is for description, whether it's clouds or sunny. Then temperature, pressure, humidity, and wind. Details are being displayed. Again, when I press London, it shows the weather details of London now. Right. So now, when I press the button again, it will get turned off. So if you want to make it for more, if you want to display the weather details for more number of cities, you can do it. So now in our project, I've used only 3 city names, right? So let's see the steps, how it works, how it's made to work. All right, so now let's start seeing the working of the project. That is the weather application using Raspberry Pi and OLED screen. So here we need to follow 4 steps. First, the circuit connections, and then installing the Adafruit library for the OLED display in order to make it work. And the third one is you need to also use an online source, that is openweathermap.org website, for fetching the weather data from online. So you get a frequently updated data so that you can make use of it by fetching it and showing it on the OLED display. And finally, so the second and third part. So the second part is for programming and configuring the OLED display, and the third one is separate one, that is getting the data from online, the weather data from online. And the fourth step is combining the second and third step, that is OLED display program with the weather fetching program. All right, so let's get started. To begin with, we can see this circuit diagram here. The circuit diagram is so simple that you just have only 5 connections to be done. It is a VCC. You can see over here that the VCC of the OLED display is connected to the 3.3 volt, that is colored in red, and ground to GND, and SDA pin to GPIO2. So this is the GPIO2, the white one, and SCL. So this is going to be the SCL. It's connected to the GPIO3. And finally, the push button. So here we have the push button that is connected to GPIO23. And the other end goes to the ground. So you can connect the other end to any ground provided on the Raspberry pins. Right. So now the next part for this is going back to the Raspberry Pi, and let's see how to install the library for the OLED display. Right, so now this is the screen of Raspberry Pi on which I will right click on the desktop and I will make a new folder. And the new folder will look like this, and I named it as libraries. Then I will click this terminal, that is the command prompt here. I need to type cd space desktop slash libraries in order to locate the libraries folder. So once I click that, I click enter, it will take me into that libraries folder. Now I need to install. So the way of installing any application in Raspberry Pi is like this, using command prompt. So I'm getting it from the GitHub. So I need to type git space clone space the HTTPS and the link. All right, so it says Adafruit underscore Python. So this is the model number for driver that we need to install. So when I click in enter, it will install on my computer. If you do it for second time, it will say that already exists on your computer. All right, so now we have installed it. Now we will get into the library. So once we have done it, we will get a folder. So this is the library package that is being installed. So inside which you will be having another folder called examples. So these are the examples that you can try out. So let's take one of the example like, yeah. So I will take this animate.py. So I'll just copy this. So I need to place it in this folder because it says it's already placed. So here we have the animate.py in the Adafruit slash Adafruit underscore Python underscore SSD1306. The reason is that when you open this on Thorny, so Thorny is the application that we will be using for programming it. So here on the third line, we are in, there is a line that says import Adafruit gpio.spi as SPI. So not this one. Oh, sorry, Adafruit underscore SSD1306. So it will immediately look for the current directory where this file is located. So it will get into this folder for checking. So that is why we are placing it over here. So when I open the Thorny again, when I click run, I'll zoom out a little. All right, I need to stop and I need to click run. As you see here, the run animate.py is already started running and it started reflecting on the OLED display that we have connected. So I will show you how it is being displayed. So this is the output of our animation project. So you can see the way the letters are moving. So if you get an output with these connections, as mentioned, it means that our OLED is being perfectly connected to our Raspberry Pi and we are ready to do the program for our weather application. All right, now, so now we have we have confirmed that our OLED display is properly working with our Raspberry Pi. Now we shall start programming for the weather for getting the weather. First of all, let's start a program to get the weather. Okay, to get the weather, you need to use an online tool, as I told you, openweathermap.org. So in this, you need to make an key. You need to generate a key using which you will be able to fetch the data. So let me show you an example here. So this is how the key looks. So this is how a number of digits, a set of digits. It's called API key or app ID. So you need to generate a URL from this website, that is openweathermap.org, by logging in. And in the place of app ID, you need to place this key here. You need to copy paste this key. And for ID means it is the ID of your city that you're going to fetch. So every city has its own ID. So if you don't know the ID, if you want to search for the name, then you can just type Q over here. You can replace the ID to Q and you can type London. So if you want to fetch the details of weather for the place London, you can do it. All right, so now let me take you to this page here. So once you place the URL on your browser, so now what happens is that it will fetch you the data here. Okay, it will fetch you a data and a set of number of uh, lines here like this. So you need to make it elaborate. You need to make the details of all the weather and temperature, pressure. So I just elaborated like this. So now once you get this output from the website, from openweathermap.org, now it's time to program to get the each details here. So this is the program for getting the details. All right, so this is the URL that we typed. So this is the program that we will be using for fetching the data from the generated URL. So this is the URL over here that we got from the openweathermap.org website. And now I need to import a library called request. So I need to type import request. For first time, it will not work for you. So you need to go to the tools, manage packages. So here you need to search for the library called request by typing request. So you need to click the first one. Yeah, after which it will give you the library version and the name that you want to install, that is Python HTTP for units. So you will get an install button here. So if you install it, the button will be turning it to uninstall. So once you have installed, you need to close the application and open so it will work properly. So now I made a variable called weather data and request weather data equal to request.get open weather map. It means that all the bunch of data that we received on the browser will be now into this, got into this weather data. So now in this weather data, we can traverse through whatever the details that we want. Okay, now we need to know the location. Location equal to weather data. That is the bunch of data. .json means you need to convert the form into JSON format. .get name. So what does that get name refers to? So you need to locate this name here. So first, the name is Chennai. So for your place, the name will be the name of your place. All right. So then I'm just concatenating it with hyphen symbol here and then weather data.json. Again, I'm converting it to JSON format. Get sys dot get dot country. Again, where is the sys here? Yeah, the sys is here, dot country. So we need to traverse through sys to reach this country origin. The country name is India. The code is I am. So when I click the run command here, you can see the output in the shell. So it says that it's Delhi, that is -n. So similarly, description cloud. So you can get the description by concatenating DESC's character with a value, the clouds. So weather.main will get you the clouds or sunny. So similarly for temperature, pressure, humidity. So there are a lot more data than this. So if you want to get your own details, like what is the wind speed and all, so you can add more details for your display. All right. So now we have completed the program. So this is the program used for fetching the data from the openweathermap.org. Next, so I will be adding all these files, important files related to our project in our description, so you can refer to that. Now, finally, we will go back to our Raspberry Pi to combine all these data to our OLED display. So this is the program for it. So here we need to start with import time. You'll be using the time here, and Adafruit. We need to import the Adafruit SST 306 library. So these are the default things that you need to import. Then import request for getting the data, RPI GPIO for accessing the button input and output. We are going to set the mode to GPIO.bc. So GPIO.setup 23 GPIO pull up down and pull is equal to GPIO PUD underscore. It means that this button will be initially in pull-up condition, that is 3.3 volts. So once you press the push button, this button will be now divert. It will be connected to, it will be bypassed to the ground. So it will become 0, that is false. So when the push button is not pressed, it will be in true condition. When you press it, it will become false condition. So initial state, when you make it as pull up down as pull up. All right. So now RST is equal to 24 for setting the reset over here for the fruit OLED display. So now we have 3 functions here: button clicked, button released, fetch weather. All right. So now let's see one by one. So the program immediately goes here while true. So the Raspberry Pi will be checking what the user is trying to do. And here we are making a button state to get the GPIO state of 23. That is the button input. If the button state is equal to false, that is when the button is pressed, then all the function button clicked. So what happens here when the button clicked? So I'm just saying on the output that the button is being pressed, and I'm making a global variable that counts. So here, and I set it to 0. And also I made a global variable called city. So I'll be using that in the program here inside this loops. So count is equal to count number 1 plus 1. It means that the count will become 1. So if the count is 1, then I want my city to be fetched for Chennai. So I will just pass the value Chennai for this global variable city. And I will call the function, and I will pass this name, this variable city inside that function. So it will immediately look for the fetch weather The Chennai is passed here. So now the display is made clear. This dot display should be done. And then this is for the OLED display program. And then we're setting the width, height of the display. These are the default things that we need to do for the display. And then we are setting a padding. This is the important thing that you need to look here. The padding means it is the spacing that we need to give. Padding is equal to 2 means. So I'm just making a space of 2 between each lines. So you can also consider that padding is equal to y axis. So y is equal to 2 and top is equal to padding. So top is y axis. So padding is equal to 2. So top is y axis. Y is equal to padding means y is equal to 2. And x is equal to padding means x axis is equal to 2. Now the y and x will be 2. Now we are getting the weather map and then weather details from the URL. And then I'm passing that details using the request.get using open weather map URL, and all the details will be fetched here. And I'll be getting the location as we saw previously in that code. And then I will draw text. So draw text is for drawing the text on the OLED display. And here I'll be setting the X and Y axis. X will be X and top will be the Y axis. Now it is 2, 2. And in that 2, 2 location, I need to I need to display the location that I fetched. And then the font and with full brightness is 2.5. And then description is at the point x is the same, it's a constant, we are not changing it, but y is changing. It means that it goes to the next line by making it top plus 10. Similarly, top plus 20 for temperature, top plus 30 for pressure, 40 for humidity, and plus 50 for wind. So you can add your own details using this. So this is how uh, we uh, we just combine the weather details fetching data program with the OLED display program. So I'm attaching all the files in the program. So if you have any queries, you can just put it on comments. Thank you.